Can UFOs actually achieve the immense speeds required for interstellar travel? One potential answer may be buried 30 feet beneath the ground in America's heartland. The Fermilab Tevatron Collider, outside Chicago, Illinois. Racing just below the speed of light, particles of protons and antiprotons are launched in opposing directions. They meet in a high-energy collision. The impact produces gamma rays, the highest energy source known in the universe, and potentially the key to interstellar travel.
The best way of making antimatter here on Earth is to employ probably the most famous equation that Einstein taught us, which is E equals mc squared, which tells us that for a certain amount of matter we can get energy. It's a great idea because it's incredibly efficient. You essentially take all of the mass in those particles and convert it into energy.
But how can antimatter exist in the universe if it must be artificially manufactured? That's the question that Stephen H. from Philadelphia texted the universe.
Stephen, antimatter definitely exists, and when it meets up with normal matter, it explodes in a burst of electromagnetic radiation. Now, we can make small bits of antimatter in laboratories, but we can also collect antimatter from space. Some cosmic rays, which are charged, very energetic particles coming from space, actually consist of antimatter.
Currently, the Super Collider is the only practical way to produce antimatter. And right now, it's created in very small quantities.
If we could figure out a way to both create and store enough antimatter, we would have a storable fuel which, when mixed with ordinary matter, would liberate a huge amount of energy at a rate way beyond what either fission or fusion can do.
Because we know antimatter exists, and we know antimatter can be created and stored, it is conceivable that an advanced civilization could create and harness the power of antimatter in sufficient quantities to create an antimatter rocket.
An antimatter ship could achieve unbelievable velocities, cruising just below light speed, nearly matching the speed of a starbeam streaking across the galaxy. Travel time from Earth to Alpha Centauri, 4.5 light years distant, about 5 years. In human terms, the cost of creating enough antimatter particles to power such a starship would be astronomical. It might be affordable in alien currency, but an antimatter spacecraft like this comes at a high price. The gamma rays from antimatter propulsion are so dangerous, they could destroy the cell structure of any living beings aboard ship. This starship would have to include an advanced shielding mechanism to keep the crew alive. And at such high rates of speed, there are equally destructive threats in the universe.
Space is pretty empty, but if you were moving close to the speed of light, you'd need an extremely effective shielding system that would allow you to be protected from interstellar dust particles that would all but annihilate a spacecraft traveling that fast.
But if space debris is so dangerous, why not avoid it completely? The solution might be one familiar to Star Trek fans, namely a starship that could achieve light speed without even moving.